Lesson 5. Review. Here's a summary of what we've done so far. First of all, we have to distinguish between odds and probability. Oh, of course, that comes up right now. Odds and probability. So we said the odds in favor of event A, it's the number of outcomes for A versus the number of outcomes against A. Those of you that are sports fans, we have the NFL playoffs going on right now. You're hearing odds mentioned all the time. So-and-so is favored 3-2 against, or 2-1 against, or 5-2 in favor. Then, if A and B are mutually exclusive, the probability of A or B, it means add. Minus any overlap. This is a special subcase. If A and B are independent, the probability of A and B, and means multiply. Oh, but be very, very careful. The odds of B might change depending on what happened with A. But and still means multiply. What are some tools? Well, one way, we can use a table. Example 1. The table shows how the students in a large high school travel to school. So I'm looking at this. I guess we have gender along the vertical, and we have mode here. Let's fill in the totals. How many kids grand total take the bus? In your head, please. 650. How many kids grand total take the car? 375. How many kids grand total use another mode? I assume walk or bike. Now let's add those up to the right. What's 650 plus 375 plus 175? You can use a calculator now if you have to. 1,000 what? Someone needs to actually crunch the numbers. I'm not doing it. What is it? Someone add it up, please, for the love of God. 1,200. Yeah, I know. Let's also add horizontally across here as well. How many males are there in the school grand total? 350, 275, 625? Yeah. How many females? Ideally, I think it should be 575 if my math is correct, but let's double check. Yep. Okay. So here is one way to break things down into their subgroups. It's using a table. Using a table. When do I use a table? If there's multiple categories that have more than 2 options. For example, if we're looking at 2 dice, I would use a table because I have 6 options for the first dice and 6 options for the second dice. So, complete the totals we've done. How many students attend the high school? 1,200. See it? Use the numbers to determine the probability of M. And we're not going to reduce these fractions. We'll leave these in not lowest terms. What's event M in this question? No, what's event M? Not what is event M? More basic. What's event M? Male. Male. How many males are there grand total? Out of? Okay, fine. Change that to a decimal. What is 625 divided by 1,200? Even? Can you read me the whole thing, please?
0.5208, 3 repeating.
So it goes on forever?
Yeah.
0.521, approximately. About 52% of the students are male. Not quite 50-50, but close. What's the probability of C given M? Huh? M. How many males? It's telling you you're in the male group. Of those, how many take a car? Is that okay? Whatever the heck that is, I really don't care about it as a decimal, but it is a decimal. Okay. That wasn't too bad, Mr. Dueck. What's the probability of M given C? Okay. What's the given car? How many take a car? 375 out of, what's the probability that you're a male? If we know that you're taking a car, so out of the 375 kids that are taking a car, how many are males?
2.
See it? 200. What's this symbol here? And. Okay. What's the probability of M and C? Now, there's two ways to do it. One way is to say, here's the males and cars out of that many total. It is going to be 200 out of 1,200. It is going to be 200 out of 1,200. But what does and mean? Well, I got to be fussy. Actually, this is going to be the probability of M times the probability of, from our formula sheet. How do we translate that? Can I steal your formula sheet for a second, Ben? It says B given A. So it says the probability of A and B is the probability of A times the probability of B given A, which I guess is going to be the probability of C given M. See how I kind of put that together from the formula? I'm just basically substituting the letters in the same locations. What's the probability of M? We answered that. 625 out of 1,200. And what's the probability of C given M? We answered that. 200 out of 625. Is that okay so far, Carson? How many 625s on the top, Carson? How many on the bottom? Turns out these are going to cancel, and you can try this on your calculator using your fraction button, but you get the answer that I already predicted, 200 out of 1,200. I could have gotten it simply by looking at those numbers. That's the probability of how many males and in cars out of the total number of students. But hopefully, Brianna, what I've also shown you, I've given you a kind of a numerical proof that and does mean multiply. It does work. It does work. I don't know if that's the clearest example or not. I'm trying this method of teaching for the first time. All right. If a student is selected at random, what's the probability that the student is female? How can I calculate it? I'll give you a hint. It's going to be something over something.
575 over 200.
That's all I want. What?
575 over 200.
575 out of 1,200. What's the probability that a student travels by bus?
650 over 1200.
Jordan.
650 over 1200.
And now we get into the meat and potatoes. What's the probability that the student is female and travels by bus? Now, one way to do this would be to realize that and means multiply. This is going to be and, sorry, let's do this. The probability of F and B is the probability of F times the probability of B given F. Say that again? Yes. But I can also get it, I'm trying to show you there's two ways to get this. And if you have the table, I'd absolutely do it that way. What if I didn't have a table? Well, then I would say, you know what? I already figured out the probability that she's female. It's 575 out of 1,200. And what's the probability bus given that she's female? Well, that's going to be 350. Sorry, not 350, Mr. Dueck. Try that again. 300 out of 575. That right there, out of that right there. And regardless, woohoo, woohoo, I get your obvious answer. What did you say the obvious answer was, kiddo? Which reduces to 1 in 4, but I really don't care. You guys, I showed you in the video lesson how to use your fraction button, right? So use it to reduce. And the only reason I say use it to reduce is I know the answer key reduces. And on the tests that I'm creating for you, the test bank probably has answers reduced from multiple choice. So, but I, again, find much more use in not reducing. Identify the following events and determine the probability that, okay, a female student travels by bus. Say what? This is the probability. We know the student is female. Given that the student is female, we want the probability that they travel by bus. Now, this is a little weird, Darian, because the word female appeared first, but it appeared second in my statement, because turns out English and math are backwards from each other. Sorry, but they are. If you know the student is female, what's the probability that they traveled by bus? Well, it's going to be, let's see. We're in the female category, so it's 575. Of those, how many took the bus? 300. Oop. There we go. What's the probability that a student who drives to school is male? So this is tricky to translate into math. What are they wanting me to find? The probability that they drive or the probability that they're male? So this is going to be find that they're male given that, what's the subgroup we're supposed to look at? What do we know? Do we use C or D? C. They drive a car. Okay. What is the probability, if we know that you drive a car, which means we're going to be out of what? How many kids drive a car? 375. What's the probability that you're a male? 200. Are the events the student is female and the student travels by bus independent? Are they independent? Well, if they were independent, that would mean that would be just multiplying them together. Multiplying the probability of female times the probability of bus. This is an abstract, this is a tricky concept. First of all, what's the probability that they're female and ride the bus? 300 out of 1,200. Or, if I go to lowest terms. Now, to see if they're independent, if I go probability of female times probability of bus, see if I get the same answer. What's the probability that they're female? 575 out of 1,200 times. What's the probability so they ride the bus? 650 out of 1,200. If I multiply that together, menu 575 out of 1,200 times 650 out of 1,200. I get 299 out of 1,152. So these are not equal answers. So not independent. That's a very confusing concept. So stay here on this, once you write that down, stay here, and I'll bring you up back to the formula sheet, which you also have in front of you. But you guys stay on this page. I'll bring it back in a sec. Here's what we've said. If they're independent, and is just multiply the probability of A times multiply the probability of B, and you'll get and. Now, we could calculate and from the table by counting. We could say, you know what, there's 300 females, 1,200 students, 300 out of 1,200. When we tried doing this side, we didn't get the same answer. What that's saying is somehow you would need to take into account whether or not A occurred. I don't know if that's the best explanation. Let's keep going. Turn the page. Trees. Matt, these are my favorite. This is what I am the best or the most comfortable with when it comes to solving probability questions. This is my safety net, my fallback. So formulas is not my forte, which is why I don't feel like I've taught this all that well. But you guys are my guinea pigs to see whether you puzzle this out or not. Mac, you gonna make it? Yeah. I'm gonna go about 10 more minutes. I'm gonna shut up. Students are given the following problem to solve. The odds that Ava will pass math are 4 to 1 in favor. The odds that she'll pass English are 1 to 9 against. If these events are independent, find the probability that she'll pass math and English, math but not English, math or English. Okay. Well, first thing I would do is I would express these in terms of probabilities. What's the probability that she passes math? If the odds are 4 to 1 in favor, how can I turn that into a probability of passing math? I'll give you a hint. 4 out of. What? No. Can't be 4 out of 1 because it can't have a probability bigger than 1, right? This is impossible. You're saying there's a 400% chance of it happening. That's nonsense. Where'd the 5 come from? What you're saying is out of 5 possible outcomes, 4 are in favor, 1 is against. 4 out of 5 chance of passing. By the way, by a lovely extrapolation, what's the probability of not passing math then? Do the math in your head, please. 1 in 5. Okay. Now, the English, they gave me against. In fact, the English, they gave me against passing. What's the probability of not passing English? 1 out of 10. What's the probability of passing English then? 9 out of 10. Let me pause and let you think about that. Is that okay? By the way, this is why I'm not a huge fan of odds. I really have to think to not trip on my brain. But I also know odds are more widely used in the quote-unquote real world. So, okay. Says some students chose to use probability formulas. Oh, they did tell me the events are independent. We should underline that. I'll underline that in red. So, Rachel, what's the first thing they want me to find? Find the probability of what? This one here.
Oh, math and English.
Say it again.
Math and
What was the middle word?
and
Now, the fact that they're independent means I can just go and means multiply. The probability of math and English is going to be multiply. What am I going to multiply? Math and English. It's going to be top times top over bottom times bottom, or if you want to, you can use the fraction button and go 4 fraction 5 times 9 fraction 10. That'll give you an answer in lowest terms. Yeah, am I wrong? I can't hear you. What?
can you go with the fraction?
Sure thing. Would look like this. Got your calculator handy? 4, here's your fraction button right here. That's what 4/5 looks like.
The A, B, C button.
Times 9 fraction 10. That's how you type in 4/5 times 9/10. And you get 18 over 25, which I'm pretty sure is 36 over 50 in lowest terms. Divide by 2, divide by 2. Okay. Hey, Alyssa, what's the second? You know what? Let's put a little I there. Alyssa, what's the second thing they wanted me to find? I. Read it again. Did you say and? Okay, so they want math and not English. And the reason I can just straight multiply without getting funky, Sterling, is the word independent. If they're independent, and means multiply. Oh, Alyssa, what's math probability is? And flunking English probability is? 1 out of 10. It's going to be 4 out of 50 or 2 out of 25 if you go to your calculator. Multiplying fractions, by the way, it's the easiest operation of any fractions. It's top times top, bottom times bottom. Giancarlo. He's back. Ty, you missed your golden opportunity to be elbowing him for a change. Except, well, and you were kind of zoned too. Hey, Laura, what's the third thing they want me to find? From up here.
Math or English.
What was the middle word?
Or
What does or mean? What does or mean? Mac. So in terms of symbolic, I would write it like this. Probability of math union English sort of looks like mu. And it's going to be add minus the overlap. So what's math? 4 out of 5. What's English? 9 out of 10. And by the way, here's how you can tell this is wrong. If you add 4 out of 5, clear. If you add 4 out of 5 and 9 out of 10, you get an answer bigger than 1, and I already yelled at Brendan saying you can't be bigger than 1, minus the overlap. And what's the overlap? And holy smokes, didn't we find and in part 1? What's and? You know what? I'm going to write that here, 36 out of 50 or 18 out of 25. Now I'm going to go to my adding. I generally go to my graphing calculator. So it's going to be 4 out of 5 and 9 out of 10 minus 36 out of 50 or 18 out of 25. And hopefully I get an answer less than 1. Otherwise I've screwed up. And I do. Almost guaranteed to pass one or the other or both. By the way, what are the odds? Is he okay? Is he alive? You are alive, Mark? Okay. Okay. Hey, what are the odds of flunking both? 1 out of 50. Okay. $49 out of 50. I'll be honest. I am not a fan. I find the formulas very tricky to keep track of. So part C, this is how I would do it. Part C says other students chose to use a probability tree diagram. Now, what's a probability tree diagram? You list the outcomes. Math, not math. Look up. English, not English. English, not English. And then along the branches, you put the probabilities. What's the probability of passing math as a decimal? If it's 4 out of 5, that's 0.8. What's the probability of failing math? If it's 0.8 to pass math in your head, what's 0.2? Let me zoom in so you guys can see. So here's our tree. What's the probability of passing English? 0.9, 9 out of 10. In your head, what's the probability of failing English? And I would label the bottom branch the same. Passing English, 0.9. Failing English, 0.1. And I knew the failing English went here because that's what this branch ended in. I knew the passing English went here because that's what this branch ended in. It takes a couple of seconds to draw a tree, but once you have the tree in place, then the rules get even simpler. It's multiply down, add across. You ready? Here is M and E. Multiply down. Can you go 0.8 times 0.9? You'll get 0.72. Can you convert 36 out of 50 to a decimal? On your calculator, can you go 36 divided by 50? And please tell me, do you get 0.72? This is the probability of passing math and flunking English, which is going to be 0.8 times 0.1, which is 0.08 if I do the math in my head. Did we calculate that above? Did we do passing math and flunking English? We didn't. This is flunking math and passing English. Wait a minute, we did do above passing math and flunking English, didn't we? Did we not do passing math and flunking English? What did we get as an answer? 4 out of 50? Can you go 4 divided by 50 on your calculator? Please tell me it's 0.08?
Yep.
It is? Woohoo. Flunking math and passing English? 0.2 and 0.9. 2 times 9 is 18. I think 0.2 times 0.9 is 0.18. I don't think we calculated that one. Flunking both? .2 times 0.1, which is 0.02, which means what, Mr. Dueck? Look up. Passing one or the other or both, that plus that plus that, there's my 98%, my 49 out of 50. I'm a tree fan. Full disclosure. So pause here, finish off lesson 4 and 3 and 2 and 1 and wake up.